This is Dr. Chaudhary, Department of Mathematics, working in RMD Engineering College. In this video, I am going to explain the concept linear algebra, especially how we have to reduce the matrix into reduced row echelon form and row echelon form. Students have often doubt what is the difference between reduced row echelon form and row echelon form. We will see in this video what is the difference between these two. See the reduced row echelon form. A matrix A is said to be reduced row echelon form if A satisfies the following properties. A means the matrix. If the first non-zero element in each non-zero row is 1. If a row does not consist entirely zeros, then the number of leading zeros in each row is lesser than the following row. If the rows have all zeros, that should be written in the bottom. Suppose row echelon form alone, in the place of non-zero row is maybe another constant also. One or another number also is possible. Okay. See, the row echelon form is an important concept in linear algebra, especially when solving system of linear equations. A matrix in row echelon form can be easily transformed into reduced row echelon form, which is a unique matrix representation that is especially useful for solving system of linear equations. See, the following matrices are in row echelon form. See the matrix 1, 2, 3, 0, 1, 4, 0, 0, 1. See the first entry 1. Suppose in the place of 1 we have 3 or 4 also, it is correct only. See the leading diagonal elements. Below this leading diagonal elements 0, 0, 0. Now that is row echelon form. Okay. Now 1, 2, 3, 0, 0, 1. See 0, 0, 0. All the zeros are kept at the bottom. That also correct. See the leading diagonal position 0, 0, 0. Now this is also row echelon form. And see this one. Previously these two were square matrix. Now this one is what? Rectangular matrix. Now take the leading diagonal elements. Okay. 0, 0, 0. Now there is no problem at all. This is also row echelon form. Okay. So what is the difference between row echelon form and reduced row echelon form? Now take this same matrix. Take this leading diagonal elements 1, 1, 1. Okay. Suppose in the place of 1, 1, 1, if we have 3, 4, 5, that also row echelon form. But in reduced row echelon form, that element should be 1. That element should be 1. In row echelon form, it may be A, B, C or some other elements. And make sure that, see the first entry 1, below this number 0, 0. And the second entry 1. That should be below and above number should be 0. The last one also number 1. Keep this above the two elements should be 0. Now only the row echelon form should be reduced row echelon form. Reduced row echelon form also row echelon form, but row echelon form is not always reduced row echelon form. Okay. Second, 1, 2, 3, 0, 0, 1, 0, 0, 0. So keep this all the zeros are in bottom and see that 1, 1. Keep this above the element also make it 0. Now only it is reduced row echelon form. And come to this one, leading diagonal element 0, 0, 0. Okay. Now this one, this entry is not 1, so don't worry about that. And here, if 1 present in the second row, the 1 present in the second entry, second row, we can make it 0. But here we no need to make it 0 here. Okay. So this one not a reduced row echelon form. This one is not a reduced row echelon form. If this 1 present here, absolutely we can make it the element as 0. But 1 present here only, no. You will no need to make 0. So this is not the reduced row echelon form. Now see the problem. Reduce the matrix 0, 2, 8, minus 7, 2, minus 2, 4, 0, minus 3, 4, minus 2, minus 5 into row echelon form and a reduced row echelon form. using the elementary transformation. See, I am taking this matrix A as it is. I am going to transform this matrix by elementary row transformation. As by the row echelon form and reduced row echelon form, we need this starting entry should be non-zero. So here 2 and minus 3 is there, and we can swap first and third or first and second. I am going to swap second and first. Okay, so 2 minus 2 4 0 comes first, 0 2 8 minus 7 keep it as a second row. Okay, and this rule is okay. Below this number pivot element 2, this entry is 0, but we have one more term is there minus 3. We need to make it minus 3 as 0. So what I am going to do, using the elementary row transformation, I make this R3 as in spite of making minus 3 as 0, I have to multiply 3 in this first row and multiply 2 in the third row. What happened here? 6 and here minus 6. Well, we add 6 and minus 6, answer comes 0. So the entire R1 and R3 also we do the same one. So 3 into R1, what happened? 6 minus 6, 12, 0. And 2 into R3, minus 6, 8, minus 4, minus 10. Okay, adding this 2, what happened? 0, minus 6, 8, 2, 12 minus 4, 8, 0 minus 10, minus 10. So substitute here, replace R3 by this value 0, 2, 8, minus 8. Look at this leading diagonal elements, okay. Below this pivot element 0, 0. First condition is okay. Second, below this number 2 is there. We need to make it 2 as 0. See, very simple. Subtracting R2 minus R3, what happened? 2 minus 2 becomes 0. So we can subtract second row and the third row, 2 minus 2 0, 8 minus 8 0, and minus 7 minus 10. See this answer plus 3. Okay, now see the leading diagonal elements. Okay, below this element 0 0 0. This is required row echelon form, but this is not reduced row echelon form. Okay, now we reduced to reduced row echelon form. As per this definition, we have to make it first entry should be non-zero element should be 1. So here starting with the 2 only, no, divided by 2. R1 divided by 2, what happened? 2 divided by 2, 1, minus 1, 2, 0, 1, minus 1, 2, 0. And the second row, after the 0, non-zero element 2, make it as 1. So divided by 2, 1, 4, minus 7 by 2. Okay, so third row 0 0 1, but unfortunately we don't have the third row exactly, but fourth row also it satisfies the condition 0 0, here 3, make it 1, divided by 3, 0 0 1. Okay, well, now it is reduced row echelon form. No, see, below this leading diagonal elements all the entries are 0. Now see the last row 1. See this column, above these elements minus 7 by 2 and 0. This element should be 0 under reduced row echelon form. So using this elementary row transformation, I make it minus 7 by 2 as 0. So what to do? Multiply R2 divided by, multiply by 7 by 2. Okay, and multiply R3 by 7 by 2 and add with R2, it comes 0. So see, 0 0 0 1, that is 7 by 2, and adding this one it comes 0. See, 0 1 4 and minus 7 by 2 plus 7 by 2, answer 0. So this entry is already 0, so we no need to apply the elementary row transformation. One more term, see this second row, second entry 1, below this number 0, above this number minus 1. So that entry minus 1 should be 0. So what to do? 1 plus 0 1, minus 1 plus 1 0, 2 plus 4 6, and 0 minus 1 by 2 minus 1 by 2. So this 0 comes to non-zero element. So elementary row transformation. If you are using elementary row transformation, here answer comes minus 1 by 2. So here you may apply elementary column transformation. So what happened? C1 plus C2. So C2 change by C1 plus C2. What happened? 1 minus 1 0, 0 plus 1 1, 0 0 0. So when we apply the reduced row echelon form, you may apply elementary row transformation as well as elementary column transformation. Okay, so here I mentioned here R1 plus R2, that is not correct. Here C2 change by C1 plus C2. This is the required reduced row echelon form. Thank you.